Hey, what's up guys, welcome back to another tutorial on TensorFlow, and in today's tutorial we are going to diverge a little bit deeper into TensorFlow. So if you just want to know how to use TensorFlow, then this lecture is totally unnecessary for you. But if you want to know the workings of TensorFlow and want to know more about TensorFlow, then let's get started. Okay, so remember that in the last tutorial I told you that all the operations in TensorFlow are performed on graphs. So that is true, but since the release of TensorFlow 2.0, there is this new function called eager execution that was included into TensorFlow. Okay, so what is eager execution? Well, eager execution is an imperative programming environment that evaluates operations immediately without building those TensorFlow graphs. So what it does is it reduces the time that is used to construct a graph and then later run it. So instead of creating a graph, you are directly running your Python code into TensorFlow. So it has another advantage, that is it allows us to remove those boilerplates that are required for TensorFlow. It is basically like running your Python code in TensorFlow. Okay, so how do we use this eager execution? Well, there are several types of tensors that are available to us in TensorFlow. For example, we created this sparse tensor. This is one type of tensor, and then there is the ragged tensor, and also there are string tensors. So the way that we create an eager tensor is we just type tf.constant and it will automatically recognize whether it's a sparse, ragged or string or any other kind of tensor. For example, over here it was a string that we had passed inside our tensor, so it automatically converted it into a string tensor. And the same goes for the rest of the tensors, and by default your tensor will be an eager tensor unless you are passing a string or a sparse matrix or a ragged tensor. Okay, so let's first create an eager tensor. So I'm going to say new tensor is equals to tf.constant, and inside there I'm going to pass my list. So I'm going to say 1 2 3, then 4 5 6 and 7 8 9. So now if I wanted to take a look at the type of this tensor, so if I just print out this tensor, the data type will be an integer. So to look at the type of this tensor, what I can do is I can say type, then inside there I can pass the name of my tensor. So if I run this now, it shows that it is of type eager tensor. So that means that we are actually running this inside a in form of a Python code. So okay, so this is what an eager tensor is. So it basically allows you to reduce the time that you spend on creating graphs, and it directly performs those calculations on its own and avoids creating those graphs. Okay, so now I'm going to show you an example of this eager execution. So what I'm going to do is I'm going to create a FizzBuzz program. So for those of you who do not know what FizzBuzz is, well, it's quite popular. So what you do is you try to find out whether a number is divisible by 3 or 5. If it's divisible by 3, then you type fizz or you print fizz. If it's divisible by 5, then you print out buzz. And if it is divisible by both 3 and 5, then you print out FizzBuzz. Otherwise you just print out that number. So let's create a function for that. Okay, so to create that function I'm going to say def, then the name of the function, that is FizzBuzz, and inside there I'm going to pass a list, so lis, and now I'm going to convert that list into a TensorFlow because we want to execute our code inside TensorFlow, not in Python. So what I'm going to do is I'm going to say tensor list is equals to tf dot convert to tensor, and inside there I'm going to pass my list, so lis, and then next we are going to traverse that list. So I'm going to say for x in tensor list. So if this x is if this x is divisible by 3 and it's divisible by 5, then I'm going to print phase buzz. Else, if it's divisible by only 3, then I'm going to print phase. So print phase. Next, if it's divisible by 5, then I'm going to print buzz. Else I'm just going to print that number. So else print x. So now if we pass in a list, so I'm going to say phase buzz, and inside there I'm going to pass a list. So I'm going to create a list. So I'm going to say x for x in range 0 to 20. Okay, so as you can see, if the number was divisible by 3, it printed out phase. If it was divisible by 5, it printed out buzz, and if it was divisible by both 3 and 5, it printed out phase buzz. Otherwise it just returned us these numbers. Okay, so this was an example of how we can use eager tensors and how eager executions help us in performing calculations without creating graphs. Okay, so now we are going to take a look at how much difference does using a GPU over a CPU makes. So first I'm going to import time so that I can know how much time it took. So now I'm going to create a function. Let's call it op. And inside the function I'm going to create a matrix that is going to be a square matrix of a random normal distribution. So I'm going to say tf dot random dot normal, and inside there I'm going to pass in the size of my matrix, that is going to be 1000 and 1000. So this will create a random distribution of 1000 into 1000 points. So next I'm going to store the start time. Start is equals to time dot time. So now we need to create a loop so that we can okay, so the size of this matrix is not enough for us to know how much difference does this make, because this level of calculation is quite easy for a CPU to perform. So we are going to repeat it for some x number of times. So I'm going to say for underscore in range 200, and inside there I'm going to just perform matrix multiplication. So I'm going to say tf dot matmul, and inside there I'm going to pass my normal distribution matrix, so x comma x, and after that I'm going to store the ending time. So time dot time, and then I'm going to return the time it took to execute that code. So end time minus the starting time. Okay, so now if I run this, so it took me this much time. So if I try to use different devices, for example, if I try to use GPU instead, this one must be okay. We'll take a look at what physical device we were using. So what I'm going to do is I'm going to say with tf.device, and inside there I'm going to pass the name of my physical device. So let's first take a look at CPU. So I'm going to say CPU 0, and inside there I'm going to call my function, and since it's returning something, I'm going to print the time that it is returning. So if I run this now, it took us 1.58 seconds. So now if I try to use GPU, and if I run this now, okay, so TensorFlow was using GPU instead of CPU over here. So as you can see, using the CPU it took us 1.6 something seconds, and using the GPU it took us a lot less time. So so this is how much difference using a GPU over a CPU makes. So next we are going to take a look at okay, so do you see this B over here? Well, what this B means is that our strings are in form of bytes. So what if we did not want our strings to be in form of bytes, and instead we wanted them to be in some other forms such as Unicode or integers? So let's take a look at how we can do that. Okay, so now I'm going to create a string tensor. So I'm going to say x is equals to tf.constant, and inside there I'm going to pass my string. So I'm going to say string, and now if I run this and try to print x, and as you can see it is of type string, but its encoding is in bytes. So I don't want it to be in bytes, I want it to be in some other form. So what I'm going to do is I'm going to decode it. So to decode a tensor, what we can do is we can say tf.io.decode. So if you press tab over here, then you will find that there are a lot of things that you can decode, but for now we are going to take a look at decode raw. So what I'm going to do is I'm going to pass in my tensor inside there, so x, then afterwards I'm going to pass the type of decoding that I want. So I want tf dot let's take a look at what kind of decoding we can do. So let's take a look at int 8. It will convert our string into a 8-bit integer. So if I run this now and try to print x again, as you can see our characters were converted into strings. So you can also do 16. So the reason that it didn't work before was that because we did not have enough characters. For example, if I say string, then I type in 1 and 2, and now if I try to do it, it won't give me any error because we have enough characters. And to create a single 16-unit or 16-bit integer, we need 4 strings or 4 characters to be inside our string. So I can include anything that is a multiple of 4, but to accommodate 8 you only need about 3 characters. So if I say str and then run this, it should not give me any error because I already have 3 characters in there. Okay, so that was how you can decode your string into some other format. So I did it into an int 8, so it is of Unicode type, that's why we are using this U over here. Okay, so we created a sparse tensor in the last lecture, but we were not able to see what it looks like. So today I'm going to show you how you can look at your sparse tensor, or what are the values inside your sparse tensor. So I'm going to say x is equals to my sparse tensor, and now if I wanted to work with x, if I try to print x first, then it will say that it is a sparse tensor, but it will not show it to me. So to see my sparse tensor, what I can do is I can say tf.sparse, then 2 dense, and inside there I can pass in my tensor and it will print out my tensor for me. So this was my sparse tensor that I created in the last lecture, and now we are able to see what it looks like. So next, there are some useful tensors that we can create. For example, if you wanted to create a tensor of zeros, so what you can do is you can say x is equals to tf dot zeros, and inside there you can pass in your dimensions. For example, if you wanted a 2-dimensional, you can just pass in those 2 dimensions. For example, so if I wanted to have 6 elements in a single dimension, so I can say 6, and if I wanted to have 5 elements in the next one, I can say 5. And if I run this now and try to print x, and it has 6 over here and 5 in this dimension. So I can also increase my dimension, so I can say 11, and now if I try to print this, it has 11 dimensions over here, 5 elements over here, and 6 elements in this dimension. So I can also change the type of my data. So right now it is in float 32. I can say tf dot int 32. So now it was converted into an integer. I can also say 64 or anything else that I want. Also, what I can do is I can use string instead of tf.int. So to do that, I'm going to say dtype is equals to int 32. So as you can see, it returned me the same result. So next we are going to take a look at how we can create a array of ones. So if you wanted a tensor that had all ones in it, so what you can do is you can say 1 instead of 0, so ones, and if you run this now, it has ones instead of zeros. So next we are going to take a look at how we can perform some shorthand operations. So I'm going to create another array or another tensor, sorry. So I'm going to say y, and it is 2 times my x. So if I run this now and try to print y, as you can see, it is an array of 2. So now if I wanted to perform operations, I don't really need to use those functions. I can also use these shorthand operators. So if I wanted to add these 2 arrays, what I can do is I can say x plus y, and it will add those 2 arrays. And if I wanted to subtract these, so I can say x minus y, and it will subtract these 2 arrays. And I can also multiply and divide. So next, if you wanted to perform a matrix multiplication on these 2 arrays, so first, to perform matrix multiplication, you must follow all the rules of matrix multiplication. So I'm going to reduce my dimensions. So I'm going to say create square matrix instead of these rectangular ones. So these are going to be my square matrix or my square tensors. So instead of this slash, I can put @. So @, and if I run this now, it will perform matrix multiplication. So as you can see, when I ran this, it performed matrix multiplication on my tensor. Okay, so that was how you can use shorthand operators to perform arithmetic operations on your tensors. Okay, so next we are going to take a look at how we can get the maximum value from your tensor. So I'm going to create a new tensor, and I'm just going to copy this one. So now if I wanted to find the maximum value, which is going to be 15. Okay, so if I wanted to find the maximum value inside this tensor, what I can do is I can say tf dot reduce max. And as I told you before, reduce is used when we want to work on a single tensor. So I'm going to say reduce max, and inside there I'm going to pass in the name of my tensor, and it should return this 15 over here. So if I run this now, and it will return me the value 15. So now if I wanted to get the index of the maximum value along each row, so how can I do that? Well, I can say tf dot argmax, and inside the function I can pass the name of my tensor. So if I run this now, it will return me the maximum values in column wise fashion. So to illustrate this better, what we can do is we can put 40 over here. So if I run this now, as you can see, this was also changed to 1. So that's because we were checking column wise. So in column 1, that is 1, 40 and 7, the maximum value is 40, that is at index 1. So what if we wanted to get the maximum values in row wise fashion? By row wise I mean, what if I wanted to find the maximum values in 1, 2 and 3? So to do that, what I can do is I can pass another argument called axis, and I can set it equal to 1, and that will return the value in the row wise fashion. So in the first row the maximum value is 3, second row maximum value 40, and the third row maximum value 9. So the index 2, 0 and 2 was returned to me. So if I change this to 0, and that will be the default value, so by default the axis is always 0, and that will return me the column wise maximum value. So as you can see, 1, 1 and 2. Okay, so next I'm going to show you a activation function that is called softmax. I'm going to change the data type of my tensor. So I'm going to say tf dot float 64, and now if I want to find the softmax, to access the softmax function, I need to type tf dot nn, that stands for neural network dot softmax. Well, this one is in neural networks because it is the activation function and it is used quite a lot. Now I'm going to pass in the name of my tensor, so new tensor, and if I run this, it will return me the softmax values of my tensor. And for those of you who do not know what softmax does, well, it actually reduces my values to between, so it converts my values between 0 to 1. So the range of all my values has been changed to 0 to 1. So all these values are in between 0 and 1. Okay, so that's it for today, and if you have any questions regarding today's tutorial, you can leave them in the comments below. And if you thought this video was helpful, then you can like and subscribe, and if you want to be notified every time I drop a new video, you can turn on the notifications. Okay, I'll see you in the next tutorial.